Imagine this for a moment. In the deepest silence of space far beyond, Earth's atmosphere instruments built by the most advanced scientific organization on the planet detected something that didn't to behave like matter, didn't follow energy models, and didn't obey prediction algorithms trained on decades of data. Not a signal with a clear origin, not noise, not an error, a pattern. A discovery so strange that even NASA scientists paused, recalibrated, checked their assumptions, and admitted something rare in modern science. We don't fully understand what we're seeing. And that moment, that pause, is where this story truly begins. Because the most fascinating part of this discovery is not only what was found in space, but what it reveals about the human brain, perception, and the limits of understanding itself. The universe didn't just challenge our technology. It challenged the system that interprets reality inside our heads. When NASA encounters an anomaly, the first reaction is never excitement, it's skepticism. Sensors are checked, models are rerun. Human bias is suspected. Because science knows something psychology has taught us for decades. The brain is not a passive observer of reality. It is an active prediction machine. Your brain constantly guesses what should happen next. And when reality aligns with that guess, you feel certainty. When it doesn't, you feel discomfort. This discovery created discomfort at a systemic level. The data showed structured behavior where randomness was expected. Fluctuations that appeared coordinated as if energy itself was adapting. Not alive in a biological sense, not intelligent in a sci-fi sense, but organized in a way that current frameworks couldn't explain. And here is where neuroscience quietly enters the story. The human brain evolved not to understand the universe, but to survive within a narrow slice of it. Our perception is optimized for predators, social signals, and energy efficiency, not cosmic truth. Vision itself is a controlled hallucination, a reconstruction based on limited sensory input. Your brain fills gaps, it smooths uncertainty, it simplifies complexity. That's neuroplasticity at work, constantly rewiring based on what helps you function. But when something exists outside those learned patterns, the brain doesn't immediately see it, it resists it. NASA's discovery forced scientists into that resistance zone, where data exists but meaning collapses. This is where stress responses activate, not emotionally, but cognitively. Under uncertainty, the brain narrows focus, defaults to known models, and protects itself from overload. In psychology, this is called cognitive homeostasis. In neuroscience, it's a protective constraint. The brain is a system designed to limit chaos, not embrace it. That's why paradigm-shifting discoveries often feel wrong before they feel true. Think about how quantum mechanics once sounded absurd. Particles existing in multiple states. Observation changing outcomes. At first, the human mind rejected it. Not because it was false, but because it violated intuitive perception. The same tension appeared here. The anomaly suggested that space itself may have properties we've underestimated. Not empty, not passive, but responsive under certain conditions. NASA did not claim a new force or intelligence. They did something more honest. They said the models are incomplete. And that admission is profoundly human. Because the brain, much like scientific theory, operates on predictive coding. It builds internal models of reality and updates them only when prediction error becomes too large to ignore. This discovery generated a prediction error too large to dismiss. And when that happens, neuroplasticity is forced to engage at a collective level. Science rewires itself. This is not weakness. This is intelligence. Yet here's the twist most people miss. The feeling of confusion, the sense that we don't know, is not a failure state. It's a protective adaptation. When your brain encounters something beyond its processing capacity, it slows interpretation, it creates uncertainty, it withholds meaning. That hesitation is what prevents hallucination, delusion, and false certainty. The same mechanism that makes you doubt yourself under stress is the same mechanism that keeps science honest. In that sense, the anomaly didn't expose a limit of technology, it exposed a limit of perception. We often imagine human understanding as an expanding circle, always growing outward. But in reality, it's more like an adaptive network, strengthening some pathways while temporarily shutting others down to preserve stability. The brain is an energy management system. Every thought is a signal. Every belief is a stabilized pattern of neural firing. When incoming data threatens to destabilize too many patterns at once, the system resists. That resistance feels like fear, confusion, or dismissal. But biologically, it's protection. And this is where philosophy quietly merges with neuroscience. What if the universe is not stranger than we imagine, but stranger than we can imagine with the brains we currently have? NASA's instruments may be detecting phenomena that require a different cognitive lens to fully understand. Not more intelligence, but different intelligence. Evolution shaped our minds for survival on Earth, not comprehension of cosmic-scale processes. The discovery forces us to confront an uncomfortable idea. There may be aspects of reality that exist beyond intuitive access, not because they are mystical, but because our neural architecture compresses reality into manageable models. Even time itself is a construct shaped by perception. The brain doesn't experience time directly. It experiences change, memory, and prediction. In extreme environments, time perception breaks down. Astronauts report altered sense of duration. Stress changes temporal resolution. Under uncertainty, the brain stretches moments. NASA's anomaly may be interacting with space-time in ways that feel alien only because our brains evolved to experience time linearly. Now consider the metaphor of the human as an energy network. Your nervous system runs on electrochemical signals. Thought is not abstract, it's physical. Patterns of energy moving through biological circuits. The universe at its core is also energy structured by laws. When NASA substructured behavior in what should be chaotic space, it wasn't discovering something supernatural. It was discovering organization where none was predicted. And organization is the language both brains and universes seem to speak. But here comes the most counterintuitive insight. The moment you feel intellectually weak, when you think, "I don't get this," is often the moment your brain is working at its highest protective intelligence. Neuroscience shows that uncertainty activates deeper processing networks. The default mode network quiets, attention systems engage. The brain shifts from automatic interpretation to exploratory mode. That discomfort you feel when faced with the unknown is not ignorance, it's preparation. NASA scientists didn't too rush to explain the anomaly, because explanation too early would have been a cognitive error. In science, premature certainty is more dangerous than uncertainty. The same applies to your life. Stress responses, mental blocks, moments of doubt are often interpreted as failure. But biologically, they are signals that your system has encountered something that requires adaptation, not reaction. Neuroplasticity doesn't happen in comfort. It happens in challenge. When neurons fire in unfamiliar patterns, the brain rewires. That rewiring feels unstable at first, just as scientific revolutions feel uncomfortable before they become normal. Today, GPS systems rely on relativity, a theory once considered absurd. Tomorrow's technologies may rely on understanding phenomena we currently label unexplained. And here is the philosophical weight of this discovery. The universe does not owe us comprehension, but it invites exploration. Each time science encounters something it cannot yet explain, it expands not just knowledge, but humility. And humility is a cognitive strength. It keeps perception flexible. It prevents dogma. It allows growth. NASA's anomaly reminds us that intelligence is not about having answers. It's about knowing when your model of reality needs updating. In psychology, rigid belief systems correlate with anxiety and error. Flexible cognition correlates with creativity and resilience. The brain that can say, "I don't know," is the brain most capable of learning. The same applies to civilizations. This discovery did not break science, it strengthened it. It highlighted that even at our most advanced, we are still beginners in understanding reality. And that is not frightening, it's inspiring. Because it means there is more to discover, more to understand, more to become. The universe remains an open question, and so does the human mind. Perhaps the strangest part of this discovery is not that NASA can't explain it yet, but that our brains instinctively want an explanation immediately. That impatience is evolutionary. Uncertainty once meant danger. But in the modern world, uncertainty is the birthplace of insight. The next breakthrough will not come from forcing answers, but from allowing questions to exist long enough for new neural and scientific pathways to form. So, the next time you hear that science has found something it can't explain, don't hear weakness. Hear intelligence pausing. Hear perception expanding. Hear the sound of the human brain standing at the edge of its current limits, ready to grow. And ask yourself this. If the universe is capable of surprising the smartest instruments we've ever built, what undiscovered potential might exist within the most complex system we know, the human mind? If this kind of science-driven curiosity resonates with you, if you enjoy exploring the edges where neuroscience, psychology, physics, and philosophy meet, then support MindSpark Science by liking this video, sharing your thoughts in the comments, and subscribing to the channel. Because the future of understanding doesn't belong to those who claim certainty, but to those brave enough to question it.